morning, students. This is Dr. Eustace Russell, working as Assistant Professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are seeing the subject called Kinematics and Dynamics of Machinery, subject code of MR3451, coming under the regulation of 2021 for the fourth semester for the second year students. So, in the previous videos, we have completed so far balancing of rotating masses and balancing of machines. In the last video, we have seen the vibration introduction and the basic definition in the vibrations we have completed. And some of the few expression also we have covered in the previous slides. Today we are going to see some basic problems of free vibrations that is important for our examination point of view. We will see one by one. Based on the formulas, we will solve these problems. So in this, we have covered already free vibrations, equations of motion. Last class we have seen the whirling speed and critical speed of the simple shaft also we have noticed. Today based on that we will have some basic introduction problems, example solved problems you will see one by one. Now this one problem for you, kindly note down. A shaft of diameter 10 millimeter carries at its center a mass of 12 kg. It is supported by two short bearings, center distance of which is 400 millimeter. Find the whirling speed. Some conditions is given. First is neglecting the mass of the shaft, considering the mass of the shaft, second condition. And another one, given condition, given values, density of the shaft material is given as 7500 kg per meter cube. Young's modulus E is given as 200 giganewton per meter square. Then based on that, students, you must know how to take the given data from the problem. That is must. Without given data, it's very difficult to solve this kind of problems because these are formula based. First, you have to capture all the data. What is the diameter D? It is 10 mm. It is clearly given in the problem. That is 0.01 meter. Mass is nothing but 12 kg. Rho, that is density, 7500 kg per meter cube. Young's modulus E equal to 200 giganewton per meter square. Giga is nothing but 10 power 9, then Newton per meter square. These are the data you have to find out whirling speed by neglecting the mass of the shaft, one condition, then considering the mass of the shaft. These are the two conditions it is given. Then going on to the solution. First you must know that shaft supported in short bearings is assumed to a simply supported beam. We have to make an assumption. It is clearly given in the problem. Is supported in short bearings. So we have to take as a SSB. This is nothing but simply supported beam. The given shaft is already given in the figure. We have already seen in the previous slide. Density is given as 7500 kg per meter cube. Therefore, mass, we can use the formula area into length into density. Area is nothing but pi by 4 d square. Unit length 1. Density 7500. You will get 0.589 kg per meter. Then moment of inertia for a rod actually this is. Therefore, moment of inertia I equal to pi by 64 d power 4. That is nothing but d is nothing but 0.01. Just you have to substitute in diameter d. Then power of 4 we will get 4.91 into 10 to the power minus 10 meter power 4. By this we are finding the moment of inertia. Then this slide will have represents the static deflection due to mass of 12 kg. at point C. So this every formulas already we might have studied. You might have studied in strength of materials how to find the deflection. That formula we are using again here. Okay. So what is that? We are using the same formula again here. W A square B square by 3 EI. What is that? Already we know the formulas clearly. Just upon substitution, you will get the values. A equal to 0.2 meter and B equal to 0.2 meter. Just we are going to substitute the value and get the values. The static deflection due to the mass of the shaft, that is nothing but 5 by 384 into WL power 4 by E I. 5 by 584 into 0.589 into 9.81. Why are using 9.81 means for converting the kg into mass. Therefore, that is nothing but kg to Newton. For that only we are multiplying by 9.81. You will get 1.961 into 10 to the power minus 5 meter. Then neglecting these two conditions is clearly given in the problem. First condition, what is the first condition? Neglecting the mass of the shaft. For that, what you have to use? Fn equal to 0.4985 by root of del. Just use the values, you will get 12.47 hertz. We know that the whirling speed of the shaft in RPS is equal to the frequency of the transfer vibration in hertz. Therefore, whirling speed, that is n equal to 12.47 RPS. Convert into minute, multiplying by 60, you will get 748.22. Then considering the mass of the shaft, again you have to use the formula 0.4985 by, you have to use this formula. That is, one thing we have to notice that considering the mass, we have to consider the deflection also, del S. Then you will get the value 12.4 hertz. Therefore, whirling speed equal to, again convert this into minute, we will get 744.63 revolutions per minute. Then next problem, again this is a UDL is given, uniformly distributed load. One problem is there, followed by the point load is also given. This is also important problem. Now go on to this problem. A shaft of 30 millimeter diameter and 1.5 long has a mass of 16 kg per meter length. It is simply supported at the ends and carries three isolated loads of 1 kilonewton, 1.5 kilonewton and 2 kilonewton at 0.4 meter, 0.6 meter and 0.8 meter respectively from the left support. Find the frequency of the transfer vibrations neglecting the same condition, neglecting the mass of the shaft, and the second condition is considering the mass of the shaft. The Young's model is given as E equal to 200 gigapascal. First you have to note down all the given data. D equal to 30 mm, convert into meter, therefore 0.03 meter. Length is equal to 1.5 meter. Mass is equal to 16 kg per meter. Young's modulus E equal to 200 gigapascal, therefore 200 into 10 to the power 9 Newton per meter square. These are the two values. You have to main thing to find the frequency of the transfer vibrations. Two conditions which I already told, neglecting the mass of the shaft, considering the mass of the shaft. This is a sketch for your reference. Same thing, first thing you have to find the mass moment of inertia of the shaft. Therefore, I equal to pi by 64 d power 4. You will, based on substitution, you will get 3.976 10 to the power minus 8 meter power 4. Static deflection is nothing but, again we are using the formula W A square B by that is 3 EI 1000 into 0.4 square into 1.1 square divided by 3 into 200 into 10 to the power 9 into 3.976 into 10 to the power minus 8 into 1.5. Then based on the substitution calculation, you will get 5.41 into 10 to the power minus 3 meter. Similarly, static deflection due to the load of 1.5. That load should be taken into account for 1.5 means the same values. Only what are the things will get changed? Weight will get changed. That is 1500. Then B also will get vary. The previous one is 0.4 and 1.1 meter. Here it is 0.6 meter and 0.9 meter. Then you will get the answer as 0.01222 meter. Then static deflection due to the load of 2 kilonewton. Again we are applying the formula. Same formula again we are using. Only A and B value will get vary. Then again based on the substitution we will get these values. We will get the values one by one for the 2 kilonewton also. Now static deflection due to the mass of the shaft, that is UDL, that is del equal to 5 by 384 into WL power 4 by EI. Upon substitution you will get 1.301 into 10 to the power minus 3 meter. Then you have to apply the two conditions. First is neglecting the mass of the shaft means only we have to add all the deflections, del 1, del 2, del 3. Then the formula we will be using 0.4985 upon square root of summation of all deflections. You will get 2.659 hertz. Considering the mass of the shaft means then del S will come by 1.27. We have to use Duckerley equation. This is actually that equation. Based on that only we are having this expression. Upon substitution you will get 2.62 hertz. So this is the reference which I use for preparing this content. Kindly go through these references. Thank you students for your kind attention. Kindly go through the problems. That will be useful for you. Kindly subscribe this channel. Share this video to your friends. So we successfully completed the unit 5 of this subject called kinematics and dynamics of machinery. Kindly go through it. All the best. Thank you.